Here's problem number 29 from section 8.3. Let's have a contest and see who's the slowest and who's the fastest in this batch. I'm going to start with these two that are almost identical and see how they fare against each other. The limit as x approaches infinity of e to the x over e to the half x. Now, I'm thinking there's no reason why I can't take this expression and change this to e to the x to the 1/2. I mean, what do you have? You got two things with the same bases. X minus x over 2 is x over 2, isn't it? Yeah. So when I do that, what happens when I go to infinity? This thing goes to infinity. Therefore, which one's faster? E to the x faster than e to the x to the 1/2. Right? Now, let's try the limit as x goes to infinity of e to the x, x to the x. Now, this seems to me like this could be rewritten as limit as x goes to infinity of e to the x to the x. Now, I'm going to choose, no, what I'm going to do, I'm going to choose to flip this around. Let's put x on the top and let's put e on the bottom. X on the top, e on the bottom. And I think it's pretty clear that this thing goes to infinity. As x gets really big, I'm dividing it by some constant. There's still going to be a really big power to a really big power. This is infinity to infinity. That's going to infinity. So therefore, e to the x, or x to the x, is faster than e to the x. So let's do one more, and let's do the limit as x approaches infinity of natural log x to the x, x to the x. Now let's go e to the x. Now again, using that same trick, the limit as x approaches infinity of the natural log of x divided by e, all to the x power. This is natural log of x divided by some constant. Well, dividing it by some constant, as natural log goes to infinity, this is still going to be infinity even if you divide it by 2.71. So this goes to infinity. Therefore, natural log x to the x is faster than e to the x. Now, the last pair I'm going to try is natural log x to the x over x to the x. Now what happens here? Same trick. Now, my impression here is that this is going to go to 0, but this is going to infinity. This is indeterminate in the form of 0 to the infinity. So let's do a little bit of side work. Let's do the trick where I take the natural log of x over x to the x, and I get x times the natural log of x over x. And then when I take the limit of that, I get x times the natural log of x over x. That's infinity. This is going towards 0. The natural log, this is going towards 0. The natural log of 0 is negative infinity. This is positive infinity multiplied by negative infinity. Let me get this straight again. Natural log x over x goes to 0. Natural log of 0 goes to negative infinity. This is positive infinity, so this is going to negative infinity. So this is going to end up equaling e to the negative infinity, which is equal to 0. This is bad form. But it goes to 0. I should have said something like the limit of e to the x, natural log x over x is equal to 0. But what does that mean? It goes to 0. This one's faster. So therefore, e to the x faster than natural log x to the x. So who's slowest? E to the x over 2, then e to the x, then natural log x to the x, then x to the x. That's 29.